Okay, so here's what a composite function is. It's a function that consists of two functions smushed together, okay? And not like what we did yesterday, okay? Yesterday we added, subtracted, multiplied functions together. A composite function is when another function is the input value. So we've looked at situations with functions where we had an input value of 7, we plug 7 in, and we simplify and we get something, right? Or we've had a situation where you plug in a variable, and then you simplify. A composite function is when you're going to actually plug another function in as the input value. Okay, so that's what I mean by smush them together, combining them together. Okay, so that's what this says. A composite function is made by using one function as the input value for the other function. If we have time, I will show you an illustration of what it might look like. Something that hopefully you'll find entertaining.
Is it a meme?
Kind of a meme, yes. It's a math meme, so it's sort of not a full-on meme. You'll see. So, yeah, you probably won't appreciate it nearly as much, but it's a good visual, honestly.
Have you seen the coding?
So let's talk about notation. Okay. Sometimes it's going to be written with this open circle. And one of the things that you will do is you will call this fog. Okay, that's not fog. But it can also be written like this, where g of x is the input value of f, and the way that we read this is f of g of x. And so, again, here's the g of x, and since that is the input value, we say f of g of x. And this open circle means the same thing. So yesterday when we were talking about multiplication, and I emphasized the idea that that dot needed to be filled in for multiplication, that's the reason why. If it's not filled in, it means something different. Okay?
So what's the point of it?
You're going to see. Okay? So again, g of x is the input value into f. Okay, and if you think about it, we used to have, it would have just said f of x, where x was the input value. So we're taking that whole function, g of x, and it becomes the input value. And one of the things that you'll get confused on is which function do you plug into what? And the key is you always sort of work your way from the inside out. Okay, g of x is the input value here. Now, sometimes flip it around, okay, and this is fog and goff. That's what you guys will like to say, so I'm just going to beat you to it. All right, so now this is where it flips around. Now, f of x is the input value into g. So you're plugging the function f of x into the variable locations of g. So you notice the difference in the notation. Which one gets plugged in? The one that gets plugged in is the one on the inside of the brackets, or the second function name, the one that follows the open circle. That's how you know which is the input value. And Chris asked a question like, what is this for? One of the things that we do with functions is determine their inverses. We're not doing that today. We're going to do that for you guys will be Thursday. But we need to be able to do composite functions in order to determine if two functions are inverses of each other. Okay? And that's what we're leading up to. Any questions so far? Let's look at an example. Okay, so here's the type of problems you're going to have. All right? It's going to ask you to find f of g of x and g of f of x. If they exist, and in this case they're going to exist. The only way they might not exist is if you ended up with a 0 in a denominator, and here we don't have any of that. State the domain and range for each composed function. And again, most of the time it's going to be all real numbers. But we'll look at that in a sec. Okay, so to find f of g of x, what this means is that the input value into f is the function g. So g is the input value. And I'm going to insert all of the function g of x in for x in f. Okay, so what this looks like is I'm going to take g of x, which is x minus 6. I'm going to take that entire thing and I'm going to substitute it in for x in f. And then I'm going to simplify.
Isn't it just substitution?
It's substitution and then simplification, yeah. The trick is getting the order straight, okay? Function g is the input value, and it goes into f. Because of the way that it's written, f comes first, g is the input value. If it was switched around, then f would be the input value. And we plug it into g, and we're going to do that here in a second too, because we have to do both. It asks for this and this, okay?
And that's just the answer?
Yep. So I plug it in. So I'm plugging g of x in for x, right? Because this is where x is in f, and I'm taking g of x and plugging it in. But we know that g of x is x minus 6. Okay. Now notice I wrote a different notation. It still means the same thing. F of g of x, f of g of x. Two different notations that mean the same thing. And now it's just a matter of simplifying this. Okay. So what is x minus 6 all squared?
X squared minus 12x minus 36, or plus 36.
Plus 36, correct. Remember, it's a binomial, so you have to FOIL that. Okay. And so you get x squared, so all of this here is this. X squared minus 12x plus 36. And I know some of you lost this middle term. We've been talking about that. Okay, make sure we don't do that. And then I combine my, and I'm left with x squared minus 12x plus 38. Okay, so that's f of g of x when I take g and plug it in for f. Now, we have to also find the domain and range. Here's what you want to look for domain and range. If there are any values for starting with domain that I can't have for x, is there anything that I can plug in? Is there anything that I can't plug in for x? Any value you can think of that you can't plug in here? And here's what you want to look for. You want to look for denominators, because the answers to that question, what values can't I plug in for x, those are the values that are going to make a denominator equal to 0. Obviously here I don't even have a denominator, so I can pick any value for x, and I'm not going to have an issue at all, which means the domain is going to be what? All real numbers. So I can pick anything. When the domain is all real numbers, for the most part, the range is going to be all real numbers. We could do a bunch of tests and see what I ended up with here, but we're not going to do that. So stated, and it's just not that important. The domain is all real numbers and the range is all real numbers. When we get into more complex functions, it'll become more important, but for the most part, you're always going to have both domain and range equals all real numbers. Okay?
What happens if
So now let's look at the other one. Let's look at g of f of x. I want you to give this a shot. All right. So what this means, again, what this means is that what's the input value? The function g or the function f? F is the input value. Okay. So I'm plugging the function f into g. Okay, and that's what that says there. So go ahead and give that a shot and let's see if you did it right. All right, so in this case, we're taking the function f and we're plugging it into x in g. So the function f is the input value. How many did that? Okay, so that's going to look like, I've got x squared plus 2 minus 6. There's nothing being multiplied by this set of parentheses in front or back, so I can really just drop them. Right, and then I have 2 minus 6, which is minus 4. All Alright, g of f of x equals x squared minus 4. You don't have to factor it when we're doing composite functions, even though it's factorable. How many had that? Okay, good. Domain and range. The domain is all real numbers in this case, and I need to change something real quick. So the domain is all real numbers. I can plug any value in for x, and I'm not going to have a problem. The range is different on this one though. Okay, and it's actually different on the other one too, but I just didn't want to get into all that. Since I have a quadratic, that means I have a parabola, which means I either have a maximum or minimum value. This parabola opens up. Okay. Do you know what the minimum value is? -4. It can never be smaller than -4. Okay. It can be equal to -4, but it cannot be smaller. So the range is actually y greater than or equal to -4. Okay. And the fact is, on the other one, we should have looked and found the minimum value or maximum value and done the same thing with the range. But again, like I said when we did that other problem, I know it's going to ask you to do this, but I'm really not that interested in it. So
Do you want to stop to do it then?
I want you to try it, and if you get them wrong, I don't want you to get all hung up about it, okay? Because I think it's good to think about the situation, but don't spend a lot of time on it. Don't spend a lot of time worrying about domain and range. Okay? Yeah, no, I want you to do it. I want you to do it, and I want you to try it, but don't spend a lot of time on it. Don't do research and Google and all this other stuff. If you're like, I don't know, I'm just going to put all real numbers, please don't do that for everything. Think about it a little bit. But again, don't spend a ton of time on it, because at this point, that's not the goal here. The goal here is to practice this. Alright, this kind of stuff. Alright, how many had that right? X squared minus 4 again? You had that? Alright, good. Are there any questions about it?
So